How will the war between Russia and Ukraine affect the space industry? What will the future of the ISS look like in terms of international cooperation? Can the ISS work without Russian technology, or is it going to fall on our heads? How will the isolation of one of the oldest spacefaring countries affect its space industry? What do the Russians bring to the table in terms of space technology? Can the Russian engines be replaced? Who will launch all the satellites and space probes which were planned to ride on Russian rockets? We have a lot to talk about in this tempestuous geopolitical climate, so stay tuned. It is hard to fathom how in this modern era of civilization this war was started. We're not even going to try and unravel that thread. Rogozin already does a pretty good job of getting mired in politics, and I'm sure plenty of you are going to let us know down below. So instead, we're going to focus on how this affects space technology, human spaceflight, and the future of satellites and scientific probes. A big portion of the world has sanctioned Russia, the invading party in this conflict. Dmitry Rogozin, the head of Roscosmos, responded to the sanctions against the Russian space industry. Firstly, President Joe Biden said Russian access for the space-hardened microelectronics will be blocked. Actually, this step was already taken in 2014 with sanctions in the banking, energy, defense, high-technology oil exploration and production, and designated military and dual-use goods. So not much has changed here. Roscosmos already managed to solve this task buying some old wafers from AMD, which allowed them to produce their own in-house radiation-hardened chips. Secondly, Rogozin talked about halting cooperation with Europe and the US as a response to sanctions against Russia. We've already seen actions to this effect publicly on social media. On the 26th of February, Roscosmos dismissed all 87 Russians working at the European Space Center in Kourou, French Guiana, and suspended the launches of their Soyuz rockets from there. This change would have a serious impact on Roscosmos' budget. We'll talk more on this later, along with details regarding the OneWeb constellation launches. Thirdly, the hardest question is about cooperation between Russia and the other parties on board the International Space Station. Stopping all cooperation on the ISS with them is very difficult. Let's explain. The ISS consists of 10 bigger modules in the international segment, and 6 bigger modules in the Russian segment. Where can we find the components for the life support? The Zvezda, or Star module, provides life support services for the ROS, the Russian orbital segment, but it is supplemented by some equipment in the USOS, the US orbital segment. Besides, the Nauka module in the Russian segment is equipped with life support system. There are separate systems in the Russian and American segments providing breathable air for the crew. They include the Electron system in the Zvezda module, and the similar OGS system in the Destiny module, and later the ESA built advanced closed-loop systems in the Tranquility module. These systems generate oxygen via means of electrolysis, and the generated hydrogen byproduct is then vented into space. Both segments have redundant backup systems to keep the oxygen at a safe level, for the cosmonauts and the astronauts. The two big segments have their own ways to scrub the CO2 from the station too. So the air wouldn't be a problem if the Russian and American segments were to be separated. It would be a difficult and hard task to disassemble all the connected systems because the segments are rather interconnected. Energy is the next obvious question. The segments have different voltage requirements too. The Russian segment has its own solar panels, and so does the American segment as well. The two power systems are connected via converters to allow for seamless energy transition between the systems. For cooling and heating, the segments have separate systems. There is one system which is particularly problematic, and that is the propulsion. The Russian segment has built-in thrusters, however it can be thrusted the other way with the help of docked Progress cargo spaceship. This is the cargo version of the well-known Soyuz. When it delivers food, water, and equipment to the ISS, and the station requires a boost in its orbit, the masses are calculated to have enough remaining fuel for the boost, bringing less cargo, so it should have capacity for the needed propellant. When attached to the proper docking port, it can boost the station to a higher velocity, which translates to a higher orbit. If for some reason Roscosmos decides not to do it, the space station will be gradually slowed down by the thin layer of the upper atmosphere and will lose altitude until the point when the process becomes irreversible and the International Space Station enters the atmosphere, disintegrates and falls back to Earth. The bigger modules won't burn completely and will hit the ground or the sea. If this process is carefully planned, the entering spot is calculated in a way to aim the debris into a non-frequently used, uninhabited area of the Pacific Ocean, the so-called space cemetery. It also has a name, Point Nemo. If re-entry happens in an uncontrolled way, the parts could impact anywhere in between the northern and southern latitude of 51.6 degrees. The head of Roscosmos made a note about the territory of Russia is almost completely outside this strip of the globe. Convenient, right? But luckily for us, there are alternative ways to add the needed momentum to the ISS. One of those is using the Cygnus cargo ship, in a similar way as the Progress was used. With the help of Cygnus's powerful Delta V engine, the ISS can gain some extra velocity. In fact, this was already tested in 2018. There is one major stumbling block though. The Cygnus is lifted by the Antares rocket, which uses two Russian-built RD-181 rocket engines. We finally arrive at the next sensitive topic in this badly broken situation. Roscosmos isn't going to sell any more rockets to the US. Moreover, Rogozin said, in a situation like this, we can't supply the US with our world's best rocket engines. Let them fly on something else, they're broomsticks, I don't know. Of course, Elon was inspired by this sentence, and it quickly evolved into a meme. Broomsticks. Big ol' X at the end. Excellent. Future Antares launches indeed could be in trouble, but for the American Atlas V rockets, which are using the RD-180 Russian engines, the United Launch Alliance has already received the final engine shipment from Russia last year. All of the planned Atlas V flights are secured. We were getting close on that one. For the Cygnus problem, a possible solution is to certify it for Falcon 9 launches. Using the Dragon for the ISS boost is another possibility, but the main engines of SpaceX spaceship, the Dracos, are in the opposite direction to what would be needed. These main thrusters are on the same side of the Dragon as the docking port. Coming back to the ISS, the separation of the Russian and American segments is possible. But then we have the big question that is the European robotic arm. Let me explain. The Smart Spacewalker was developed by the ESA, built by the Airbus Defence and Space Netherlands, and launched on top of a Proton rocket and docked together with the Nauka module to the Russian segment of the space station in the summer of 2021. You with me so far? Cool. It was designed to operate around the Russian segment. The Canadarm2 fulfills the same role around the rest of the ISS. The ERA robotic arm is a cooperation between ESA and Roscosmos, so its future remains a big question mark after a possible separation of the segments. Will Russia buy it from the European Space Agency? Will it be transferred to the American segment? We don't know yet, and the best scenario would be if the International Space Station didn't have to separate at all. We talked earlier on in the episode about discussing the OneWeb issue in more detail. Let's get in. The partly Indian, partly Western European, with a UK government share-owned company, has a batch of 36 OneWeb satellites in Kazakhstan in the Baikonur spaceport. The satellites were already assembled on top of a Roscosmos Soyuz 2.1B rocket, rolled to the pads, ready for launch. Then the war situation interrupted the process. Go figure. Roscosmos made demands to OneWeb seeking assurances that the satellites would not be used for any military purposes, and that the UK government should withdraw its share from the OneWeb company. These demands were not met. OneWeb called back its employees from Baikonur, and the Soyuz rocket was removed from the launch pad and hauled back to the assembly and test facility. Meanwhile, the flags of the international parties were painted over. They announced that the rocket will be used for domestic use, launching weather satellites. We don't know yet what will happen with the 36 OneWeb satellites. It's pretty much a foregone conclusion at this point that Roscosmos ain't gonna launch those satellites. It's not happening. The remaining part of the OneWeb mega constellation should be launched by other companies. SpaceX could be a possible provider, but considering that we are talking about a rival of the Starlink satellite constellation, probably the price of a launch would not be low. The opposite could be true for another possibility. The ISRO PSLV rocket could launch the communication satellite, especially as Bharti, the majority owner of the OneWeb, is an Indian company. Russia is losing business with OneWeb, but there is another big change happening on the other side of the Atlantic Ocean. Let's draw our attention to the Kourou spaceport in South America. Firstly, the spaceport itself officially belongs to France, which is a NATO country. You can see how things are getting complex here already. It's going to be a fun one. Prior to the war, ESA and Roscosmos had an agreement there. ESA built the launch complex for about $800 million for the Soyuz rockets, and augmented their own fleet with said Russian-built rockets bought from Roscosmos. In exchange, Russia would be able to use the spaceport for their own operations. Another thing worth noting here is the Soyuz can launch 1.7 tons to GEO from Baikonur. But from Kourou, that increases quite a bit to 2.8 tons. Ultimately, due to the war and deteriorating international relations, Russia decided to pull all personnel out of Kourou spaceport. They left behind 3 Soyuz STB rockets and 3 frigate upper stages. These rockets are completely useless without the launch team present. These launches were already paid too, but of this, Rogozin himself said the money for them has been received and won't be refunded due to force majeure. Only the future knows whether the events can be so classified. There were many satellites booked for flights on Soyuz rockets from Kourou, more Galileo GPS satellites, many scientific missions, and even a French military spacecraft. The Galileo satellites will be launched on the future Ariane 6 rockets, which will have their debut flight no earlier than the end of 2022. Also due to the ongoing war, another big change happened at ESA. The future of the ExoMars mission looks to be in jeopardy. This multi-part mission started in 2016, sending the Trace Gas Orbiter probe to orbit the Red Planet. Unfortunately, the Schiaparelli EDM lander landed a little harder than intended, resulting in a rapid unscheduled disassembly. Yikes. The next mission would be sending the ESA's Rosalind Franklin rover to the surface of Mars with the help of the Russian-built Kazachok lander in 2022, so this year. On the 22nd of February, we could see that that project was still on track at this time. However, by the 26th, we could see the first clouds starting to form on the horizon of the ExoMars future. It began when the EU announced that it would ban the sales of planes and spare parts to Russia, as well as any technology related to aviation or space. Initially, it looked like there was still hope. Then it all began to unravel. Rogozin announced the leaving of Kourou from where the ExoMars missions was to be launched. On the 28th of February, it was not a question anymore. The Director General of ESA, Joseph Ashbacher, said, "Regarding the ExoMars program continuation, the sanctions in the wider context make a launch in 2022 very unlikely. ESA's Director General will analyze all the options and prepare a formal decision on the way forward by ESA's member states." In our opinion, reducing cooperation, reducing common projects, and common scientific work is a big loss for humanity as a whole. Limiting business and research opportunities has also a big negative impact on the economy and science. Unfortunately, this is what we see now. We can just hope that the war will have a peaceful and swift resolution as soon as possible, and this situation will change. How could there be a team space this way? Think about what kind of future we want to see for us. Would it be like The Expanse, where groups of people are fighting against each other, or would it be like Star Trek, when humans and also other species work and live together? Yeah, that's right, I know about the Klingons and the Borg. Well, there is no perfect universe, right? Thank you for watching this episode. We hope that you enjoyed it. Hope for better days to come, and on to the future. Progress cargo spaceship. That? The well-known Soyuz. Next mission would be sending the ESA's Rosalind Franker. Franker? Okay. I thought I didn't pronounce Rosalind properly. It put me off. Oh, that went well. That went well. That's a good one.